numbers and magic squares. So this week we are going to do modular numbers, and next week we are going to do magic squares. Okay. So what is the objective of today's lesson? At the end of this class, you will be able to 1. Understand and describe modular numbers up to mod 12. Okay, and 2, you will be able to describe what is modular congruence. 3, you will be able to determine the sum, difference, and product involving modular numbers. In other words, addition, subtraction, and multiplication of modular numbers. And 4, you will be able to solve non-routine problems involving modular numbers. Okay, we have to cover all this in this lesson today. Okay. Okay, let's start with the first slide. Okay, modular numbers. Okay, before I give you the definition, okay, let's say you want to divide two numbers. You want to divide two numbers A and B. A divided by B. Okay, so when you divide A and B, you get your answer. Your answer is known as the quotient, and you may have a remainder. Say you have a remainder which we call R. So here, this is a normal division, okay? The A is known as the dividend. The B is known as the anybody? Yes, divisor. And what is the Q?
Quotient.
Quotient, yes, quotient. And your R is the remainder. Okay. So this is when you do a normal division. This is what you get. This is what each number means. Okay. But sometimes we are only interested in the remainder when we divide A over B. Okay. When we divide A over B, we only want to know what is the remainder. Okay. In this case, we cannot write A divided by B is equals to R. This is wrong, right? Okay. This will be wrong. So we can't write like this. So we write A mod B equals R. Okay? That means A modulo B is equal to R. B is the mod or the modulo. A modulo B, or we can say A mod B is equal to R. A mod B, that means A divided by B will give you a remainder of R. Okay, so example, 13 divided by 5. You know that 13 divided by 5 is 2, remainder
3.
Yes, 13 divided by 5 is 2, remainder 3. Or we can write it like this. 13 is equals to 2 times 5 plus 3, correct? There are 2 multiples of 5 in 13 plus another 3. 2 multiples of 5 plus another 3. But if we only want to look at the remainder, we write it like this. 13 mod 5 is equals to 3. This means 13, when you divide by 5, 13 divided by 5 is equal to a remainder of 3. It gives you a remainder of 3. This 3 refers to the remainder. Okay, this 3 is the remainder. R. Okay, can you understand that? So, if we have another example here, 8 divided by 5. What is 8 divided by 5? It is 1 remainder
3.
So if we want to write this like this in mode, as a modular number, how do we write this?
8 mod 5 equals to 3.
8 mod 5 is equals to 3. Okay, so 8 divided by 5 is equals to 3. We're only interested in the 3. We don't care how many times 5 is inside 8. Okay, so these are modular numbers. Okay, so a number x mod n is the equivalent of asking for the remainder of x when divided by n. Okay, so far are you clear?
Yeah.
Everybody clear so far? Okay. Modular numbers are, or modular arithmetic is also known as clock arithmetic. Okay. Have you heard about this clock arithmetic? Yeah, I think I'm going to use this one here, this picture here. Can you see this picture over here? This is the face of a clock, normal clock, right? So if I tell you the time now is 11 o'clock, what is the time in 4 hours time? The time now is 11 o'clock. What is the time in 4 hours time? Anybody? No, it's not a trick question. The time now is 11 o'clock. So what is the time in 4 hours time? 3 o'clock, right?
Yeah,
Yes?
3 o'clock.
3
Or
o'clock. So if we
4
write
hours.
11, 1, 2, 3, 4. So it's 3 o'clock, right? So if we write 11 plus 4 is equals to 3. 11 plus 4 is equals to 3. Is this correct? But mathematically, this is not correct, right? We know that 11 plus 4 is equals to 15. 15, right? Or so that it is clearer, mathematicians they write this as, it's actually 15. 15 is congruent to 3 mod 12. That means 15 when you divide by 12 is 3. So this is 1, when you reach here, is 1 mod 12. 1 divided by 12 gives you a remainder of 1. 2 divided by 12 gives you a remainder of 1 because there's 2 divided by 12 is 0. And 12 and minus 2 will give you 2, isn't it? So 3 divided by 12 is 3, 4 divided by 12 is 4 mod 12, 5 mod 12, 6 mod 12, 7 mod 12, 8 mod 12, 9 mod 12, 10 mod 12, 11 mod 12. 12 divided by 12 has a remainder of how much? 12 mod 12. 12 divided by 12 has a remainder of
0.
0, right? So that's why in modular mathematics, usually we write here as 0. We don't write that as 12. So if this is mod 12, it is 1 until 11, okay? So what is the next number after 12 is 13. 13 is equivalent to 1 mod 12, back to that. So 13 is congruent to 1 mod 12. That means 13 divided by 12, the remainder is still 1. So 13 is still is here. 13 is here. 14 is 2 mod 12. 15 is 3 mod 12. 16, 17, 5 mod 12. Until you reach here is 24. 24 is 0 mod 12. Then you come back here is 25. 25 is 1 mod 12. Again, 25 is 1 mod 12. Okay, so 25 is 1 mod 12. It means that 25 divided by 12, the remainder is 1. Okay, so 7, 13, 25, they are all at the same time. They all tell the same time. 2, 14, 26, they all tell the same time. Okay, do you understand that? This sign here is known as congruent. 15 is congruent to 3 mod 12. 13 is congruent to 1 mod 12. 25 is congruent to 1 mod 12. Can you understand that? Yes?
Yes, madam.
Okay.
Yeah.
Yes, madam.
Okay, good. So this one, 13 mod 5. It means, how do we get 3? If we want to use clock arithmetic and show this, 13 mod 5, okay? So we draw a clock face. This is mod 5, right? Mod 5 means we're only going to do up to 5 numbers here. So we always start with 0. This is actually the 5 place. No. So this is 1, 2, 3, 4, 5. But 5 we usually replace with 0. So when we say 13 mod 5, 13 divided by 5, so we start from 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So where did we stop? We stopped at 3. Okay, so 13 mod 5 is equals to 3. Okay, 8 mod 5. So 0, 1, 2, 3, 4, 5, 6, 7, 8. We stop at 3. So 8 mod 5 is also equals to 3. Okay? Can understand?
Yes, madam.
Okay. So if I tell you we have a mode 4, so mode 4, and if you want to draw the clockwise for mode 4, clock phase for mode 4, it will be, we start with 0, 1, 2, 3. Say we want to do mode 7. Mode 7 will be 0, 1, 2, 3, 4, 5, 6, 7 until 6, 4 until 3. So this is, so what is 8 mod 4? From here, 8 mod 4 is 1, 2, 3, 4, 5, 6, 7, 8. So 8 mod 4 is equals to 0. What is 11 mod 4? Use the clock face and tell me what is 11 mod 4.
Three.
3,
One.
1. Okay, let's check it out. 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Where did we stop? 3. So 11 mod 4 is 3. Why? Because 11 is equals to 2 times 4. 2 multiples of 4 plus 3. Okay? So all 11 divided by 4 is 11 divided by 4 is 2, 8, remainder 3. So we write the remainder, not this, not the quotient. We always write the remainder. When you do modular arithmetic is only interested in the remainders. So 11 mod 4 is 3. Okay? So if you can either use a clock face like this and you can draw and find the answer, or you can work it out yourself like this. So the remainder here is 3. This is the answer. Can? If it's a small number, you can use a clock face and draw. But if it's a larger number, then it's difficult to draw. Okay? So now this is 7. What is 9 mod 7? So we start from 0 here and we count 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 9 mod 7 is 2. Okay? What is 2 mod 7? 1, 2. 2 mod 7 is 2 because 2 divided by 7, it gives you a remainder of 2. Yes, gives you a remainder of 2. So 9 mod 7. Okay, what is the next number after 9? Okay, this is 1, 2, 3, 6, 7, 8, 9. Okay, so 2, 9 all have the same remainder. 2, 9, what's the next number? What else has a remainder of 2 after 9?
16.
16. How do you get that? One cycle is 7, 2 cycle is 14, plus 2 is 16. 3 cycle is 21, 21 plus 2, 23. 4 cycle is 28, 28 plus 2, 30. All these have a remainder of 2 when divided by 7. Okay, so if you're calculating the remainder for a positive number, you step according to clockwise direction. Okay, you go to clockwise direction if it's a positive number. But if it's a negative number, then you have to step anti-clockwise. For example, negative 5 mod 3. What is negative 5 mod 3? Okay, let's draw mod 3 first. Zero, 1, 2, right? 3 means we only do until 2 because 0, 1, 2, because this is actually 3, okay? 1, 2, 3, okay? So negative 5 mod 3. You tell me what is the answer. You step anti-clockwise and tell me what is the answer.
When
1, yes. It's actually equals to 1. Why? We want to go negative 5. Anti-clockwise 5. So that means we go 1, 2, 3, 4, 5. We stop at 1. Okay. So we go anti-clockwise for a negative number. If you want to draw and find the answer, if you don't want to draw, you can also find it like this. You know that negative 5 is going to divide by 3. So we take 3 times what? We give you negative 5. If we times by negative 1, okay, will give us negative 3. Negative 3 is less than negative 5. We want a number here that is more than negative 5, just over negative 5. So we take negative 2 here, okay? So negative 2 times 3 is negative 6, but we want negative 5. So we must plus how many here?
1.
Yes, plus 1 will give us negative 5. This is the remainder. We want our remainder to be positive. This is the remainder. So the remainder, so negative 5 when divided by 3, or negative 5 mod 3 is equals to 1. What is negative 9 mod 4? Calculation wise. So this is negative 9 is equals to times how much here? Mod 4. That means times by 4. We want to see how many multiples of 4. So what number do we write here? This is 9. We want something more than 9. So negative.
Negative 3.
Negative. If you
3.
write
3.
1, yes, negative 3. Negative 3 will give us 12. Negative 2 will give us negative 8 here. So we don't want negative 8 is smaller than this. We want slightly more. So this is negative 12. Now we must add how much to get back negative 9? Negative 12 plus
3.
now this is negative 12, right?
Yes, negative
So we
9.
want negative 9. So plus how much?
3.
3.
Plus 3. Is that correct?
Yes.
So this is our answer. Negative 9 mod 4 is equals to 3. Or you can draw the clock face here. You want mod 4. So 0, 1, 2, 3. Okay. Mod 4 means you must stop at 3 here. Okay. Mod 5 means stop at 5. So we want negative 9. This is 9, but it's negative. So go the other way. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have stopped at 3. So your answer is 3. Okay. So far, can you understand this?
Yes.
Everybody can?
Yes.
Yes.
Okay. Okay, let's do a little bit of practice, okay? You tell me, okay? What is 9 mod 6? Remember, 9 mod 6 is the remainder. Okay, you try all this on your piece of paper in your house, okay? And then we'll discuss the answer. Okay, number 1, what is 9 mod 6? Anybody? 3. 29 mod 3?
2.
2. What is negative 29 mod 4?
3.
3. Negative 17 mod 7?
4.
4, yes. If you have got all these answers, then you know you understand lah, okay? So if anybody don't understand, you must tell me now, okay? You need me to repeat anything? Everybody's okay?
Madam, so the
Yeah.
remainder must be positive.
Yes. Remainder is positive. Okay, so can we go on? Okay, we continue. Okay, next we have gone into the introduction of modular numbers. So now we're going to look at congruence. Congruence. So just now we introduced to you this symbol. This symbol is congruence. This is equals to. This is equal and this is congruent. Okay. So supposing we have something like this. A, how do we read this? A is congruent to B mod N, meaning that A is congruent to B mod N or modulo N. It means that A mod N is equals to B mod N. That means A divided by N, the remainder is equals to B divided by N. This remainder is equal to this remainder. When this remainder is equal to this remainder, then we can write A congruent B mod N. Okay, so two integers A and B are said to be congruent modulo N if they have the same remainder upon division by N. Okay, let's look at the example, then you'll understand better, okay? So I give you a statement here, okay? 52 is congruent to 24 mod 7. Is this true or false? Okay, let's see whether this is true or false. So let's see, okay? We know, okay, these two are congruent if 52 mod 7 is, if 52 mod 7 is the same as 24 mod 7. Okay, if these two is the same, then this is correct. Okay, so what is 52 mod 7? 52 divided by 7, what is the remainder?
3.
24 mod 7?
3.
Yes. So both the remainders are the same. Therefore, this is true. So we can write it like this. 52 is congruent to 24 mod 7. From here, we can say that 52, when you divide by 7, you get the same remainder as when 24 divided by 7. Okay. Another way of checking if this is correct or not is we take the difference of A and B. We take the difference A minus B. In this case, this is A and this is B and this is your N. Okay. So A minus B is 52 minus 24. How much is this? 28, right? So 28. Is 28 a multiple of 7? 28 is 4 times 7. 28 is a multiple of 7. There is no remainder. If 28, if this difference here is a multiple of the mode and there's no remainder, so that means this is correct. They are congruent to each other. That means A and B are congruent. Can you understand that?
Yes.
Okay, let's do one more example. 26 is congruent to 11 mode 5. Is this correct? So what must we check? We must look for 26 mode 5. We must find the remainder of 26 mode 5. What do we get here?
1.
1, yes. How about 11 mode 5?
Also 1.
Also 1. Because the remainder is the same, therefore this is correct. Now let's look at the difference. 26 minus 11 is
15.
15. Okay. Is 15 a multiple of 5? 15 is 3 times 5. So 15 is a multiple of 5. Therefore, this statement is correct. Therefore, we can say that 26 is congruent to 11 mod 5. Okay? Can you understand that?
Yes.
Okay. If I give you another question here, okay? If I say that x, okay, x is congruent to 11 mod 8. Can you suggest a value for x? There can be many values. Can you suggest a value for x? X is that means x divide and a number divide by 8 must give you the remainder of 11. Sorry, must have the same remainder as 11 divided by 8. So what is 11 divided by 8? What is the remainder?
3.
3. So what number will have the same remainder when divided by 8?
19.
19? Yes, so x can be 19. What else can x be? You know that the remainder is 3 when divided by 8. So 8 times 1 plus 3 is 11 already. 8 times 2, 16 plus 3 is 19. 8 times 3 is 24 plus 3, 27. 8 times 4 is 32. 32 plus 3, 35. 8 times 5, 40. 40 plus 3, 43. All these numbers will fit in as x, correct? Okay, let's check. X is 19 is congruent to 11 mod 8. Okay, that means 19 mod 8 must give you 3, 11, because we know that 11 mod 8 is equals to 3. So this is correct. Okay, then we check one more. Okay, 27 is congruent to 11 mod 8. That means 27 mod is give 3 and 11. Okay, so you can put in any values here to find the congruence. So do you understand the concept of congruence? Yes?
Madam,
Yeah.
Why 3 cannot be the answer for number 2?
For number 3.
Yes.
What cannot be the
Why
answer?
3 cannot be?
3. 3, yes, 3 can be the
3.
answer. 3 is congruent. You asking me why 3 cannot. You want to say 3, yeah, like this. 11
Yes.
mod 8. Yes, it is correct. 3 divided by 8 will give you 3. 11 divided by 8 will give you 3. Okay, so 3 is also correct. Good question. Okay, any other question? So when you see congruence like this, it means 26 divided by 5 is the same remainder as 11 divided by 5. That means the remainder on this side for this number should be the same. That is what you mean by congruence. When you write like this, 8 mod 5, here this equals to. Okay, then they're asking you what is the remainder. When you divide 8 by 5, it is 3. This is equals to. Okay, so this, can you see that clearly? Okay, when you write like this, you're asking for the remainder. When you write like this, you don't see the remainder here. Okay, because it is not shown in this sentence. It means the remainder of 52 divided by 7 is the same as the remainder of 24 divided by 7. That is why we write these two numbers are congruent, because they have the same remainders when divided by the same mode. Here they are asking you for the remainder. Okay, so that is congruence. Okay, so we are finished with congruence. Now we're going to go